Students, as you did resistance and its topic, so let me show you how does a resistance look like, a resistor look like. You have drawn the symbol, but this is the actual resistor. This is actual resistor. It's made up of carbon and it has some rings over it, colorful rings over it. So we can also calculate the value of resistance by noting the color of these rings, right? And then I'll show you a model where I have actual resistors with me. So this is a model you can see. Very simple. A battery is connected here and these are four resistances. You can see, have a close view. Rings are there over it. These are different resistors of different values and there is a light here, bulb here, anything you can connect. And how does the resistance vary here? This is maximum resistance R4, less than that, less than even that. This is a minimum resistance. This is the least resistance. Okay, so let us see how it works. When I bring the contact on resistor R1, you will see the light glowing. Okay, it should be maximum in this case because this was the least resistance. Then with R2, that resistance is more, so it will glow slightly less. R3 is even more than that, so it will glow dim. And this is maximum resistance, so it will glow very dim, right? So depending upon the same principle, we have regulator also. A regulator of a fan also works on the same principle. When we move the knob, you say that we are changing the speed 1 2 3 4 5. Actually you are changing the resistance. So accordingly, when you choose minimum resistance, then maximum current flows through the fan and it rotates with maximum speed. Okay, so this is how a regulator is also based on the same principle. All right. So now let us witness what are the factors on which resistance of a conductor. Whenever I talk about a conductor means I am talking about a wire. So what are the factors on which resistance of a conductor depends? Okay, so give this heading, factors affecting resistance. All right, factors affecting resistance. First factor is length of conductor or wire. Length of conductor. Conductor means wire through which current is passing. Okay, so let us see how resistance depends upon length of wire or length of conductor. See, longer will be the length of wire, more will be the path, longer will be the path for electron to go. Utna hi long path hoga electron ka, right? And so that's why what will happen? It will collide more. Okay? If length of the track is more, electron is coming starting from one end of the wire, it has to move to the other end. Then it will collide more. If the path is longer, it has to suffer more number of collisions. And since the cause of resistance is collisions, resistance is going to increase. Okay. So we come to know that resistance is directly proportional to length of wire or conductor. Reason being, if we have a shorter wire and if we have a longer wire, electron has to suffer less number of collisions in case of a shorter wire and more number of collisions in case of a longer wire, because longer will be the path for electron to go, so greater will be the number of collisions in that situation. All right, so is the reasoning clear to you that more will be the number of collisions in case of longer wire because of longer path? So that's why resistance will increase. So it is found that resistance is directly proportional to length of wire or conductor. Okay, so this is the first factor. Now the second factor is area of cross section. area of cross section of the wire. Area of cross section means thickness. Area of cross section means thickness in simple words. Okay, suppose I show you a chalk. Okay, this is cylindrical. This chalk is cylindrical. What is its area? 2 pi RH. Okay, but when I talk about its cross section is circular. So area of cross section will be pi r square, same as that due to a circle. Okay, so if the chalk or wire, it is having greater area of cross section, that means it's thicker. And if it is having a smaller area of cross section, that means it is thin. Okay, so this is how we relate area of cross section to thickness of the conductor or wire. Okay, so this is not, we are not talking about whole area of the cylindrical wire. We are talking only about the cross section. Okay, got this? So how does the resistance depend upon thickness of the wire, depend upon area of cross section of the wire? Let's see. So now we have a thick wire and a thin wire of same length. Okay, तो यहाँ पे अब जो एक इलेक्ट्रॉन आ रहा है, like you move through the corridor of the school. You imagine you are moving through corridor of the school. Okay, so then if the wire is narrow, if the corridor is narrow, and there is a lot of rush in the corridor. After assembly, you are returning back to your classes, or it's a recess. After that, you are coming back to your classes. In our school, otherwise you move in lines. I'm just talking about this situation. Suppose there is a lot of crowd, then you tend to collide with other people if the corridor is narrow. But if the corridor is wider, for example, when you go to the ground, then more space will be available to the electron. तो अगर सामने से कोई आ रहा है तो वो इधर चला जाएगा, ठीक है? तो more space will be available to the electron, it will collide less. So if the wire is having more area of cross section, more space will be available to the electron and it will collide less. अगर सामने से कोई आ रहा है तो वो उधर चला जाएगा, ज्यादा स्पेस अवेलेबल है तो कोलाइड होने के चांसेस बहुत कम है. So resistance will decrease. Okay, because number of collisions will be smaller now, so resistance is going to decrease now. So it is observed that resistance of a conductor is inversely proportional to area of cross section of the wire. Is the reason clear? Because if the wire is thicker, if its area of cross section is more, it will collide less because more space will be available to the electron. So resistance is inversely proportional to area. Fine. Combining these two factors in one, इन दोनों को एक ही में कंबाइन कर देते हैं. Yes, आदित्य शर्मा.
गुड मॉर्निंग मैम.
मॉर्निंग.
मैम हमारी क्लास में मैम कोई जयंत छाबड़ा करके आया, मैम उसको रिमूव कर दो मैम, वो हमारी क्लास का नहीं है.
So combining both the results in one formula, combining both the results in one formula are proportional to L by A, we can write. Directly proportional to L, inversely proportional to area of cross section, combining both in one. Okay, and now when we remove this sign of proportionality, we introduce a constant here, rho. We introduce a constant. This is a Greek symbol, rho. We pronounce it RHO. This is a Greek symbol, rho. But what does it suggest here? Rho is resistivity of conductor or wire. Where you can write rho is resistivity of the wire. It is also known as specific resistance. So it is not simply resistance, it is specific resistance. Okay, we'll just define it. So note kariye. So R is equal to rho L by A. This is a famous expression we are having. After Ohm's formula, we are having this formula. So note down, R is equal to rho L by A. This formula indicates on what factors resistance depends. It depends upon length of wire, area of cross section of the wire. And here what is rho? Remember, rho सिर्फ symbol का name है. Rho का मतलब क्या है यहाँ पे? That is resistivity or specific resistance. Rho is resistivity or specific resistance here. Okay, So let us define it. अब इस फॉर्मूला में if we put length equal to 1 meter, suppose length of the wire is 1 meter, area of cross section of the wire is also 1 meter square, what we'll get here? R is equal to rho 1 into 1, that vanishes. So that means rho will be equal to R. Okay, let's imagine that the length of the wire is 1 meter, area of cross section is also 1 meter square. So by putting in the values, what will be rho equal to? Rho will be simply equal to R. So this is how we can define. We'll connect all these things in our statement. It will become the definition of resistivity. So listen to me first, then I'll dictate. Resistivity is defined as the resistance. It is equal to resistance now. So resistivity is defined as resistance of a conductor whose length is 1 meter and area of cross section is 1 meter square. Got this? Okay, now write down. Define resistivity, write its unit. We are going to do this question. So write down the definition of resistivity. Resistivity is defined as the resistance of a conductor. Resistivity is defined as the resistance of a conductor whose length is 1 meter, and area of cross section is 1 meter square. And area of cross section is 1 meter square. So this thing just for remembering, this is just for your understanding. ठीक है, आपने इसको साथ में नहीं देना है डेफिनेशन में, ये मैंने जस्ट आपको पुट करके बताया है कि हाउ resistivity comes out to be resistance. So from here we come to a very important result that resistivity does not depend upon length and area of cross section of the conductor. ये उस पर डिपेंड नहीं करती है. If length of wire is something else other than 1 meter and area of cross section is something else, तो हम उसके रेजिस्टेंस को रेजिस्टेंस ही कहेंगे, resistivity नहीं कहेंगे. Resistivity we will say only when the length is 1 meter, area of cross section is 1 meter square. So that means resistivity, we come to very important result that it does not depend upon the dimensions of the conductor. Resistivity depends only on nature of material. It varies from substance to substance. For different materials, the value of resistivity will remain different, but it will not depend upon dimensions of the conductor. So please note this result down. When we will change the length of wire or area of cross section of the wire, resistance will surely change, but resistivity will remain the same. And what will be the reason for that? Resistivity does not depend upon dimensions of the conductor. It does not depend upon length and area of cross section of the wire. Got this? Now let us calculate the unit of resistivity from this expression. Okay, we'll put the units of all these things, we'll get the unit of resistivity. So give it a try. All of you try yourself. You know what is the unit of resistance? Ohm. What is the unit of length? Meter. What is the unit of area of cross section? Meter square. So after cancellation and all, after cross multiplication, who will tell me what will be the unit of resistivity? Yes, Arshin.
Ma'am, ohm meter.
Yes, it will be ohm meter. See, I do it once again. Cross multiply rho is equal to RA over L. Now let's put their units. Okay, unit of resistance is ohm, area meter square over unit of length, that is meter. 1 meter gets cancelled and we are left with unit of resistivity, that is ohm meter. Okay, so the unit of resistivity is ohm meter. Is that fine? Formula is clear to you, resistivity definition is clear, the unit of resistivity is clear to you. All right, fine. Now let's define one more term. Did I tell you what is conductance? Yes, anyone? What is conductance? Yes, Dhavnesh?
मैम मुझे पिछले के अंदर डाउट
What?
मैम मुझे पिछले के अंदर थोड़ा डाउट था।
हाँ जी बोलो।
मैम जो आपने रो और आर को रेजिस्टिविटी को इक्वल कर दिया, तो मैम ऊपर लेंथ थी, नीचे एरिया था, तो मैम मीटर से मीटर जो सा कट गया तो नीचे 1 मीटर नहीं रह जाएगा?
जब हम उसको डिफाइन कर रहे हैं ना, देन वी आर नॉट टॉकिंग, हाँ मीटर रह जाएगा, ओम मीटर होगा, बट रेजिस्टिविटी विल बी इक्वल टू रेजिस्टेंस। ठीक है, तब हम सिंबल्स की टर्म्स में बात कर रहे हैं कि इफ लेंथ को हमने 1 पुट कर दिया, एरिया ऑफ क्रॉस सेक्शन को भी 1 पुट कर दिया, मैग्नीट्यूड 1 1, ठीक है, तो रेजिस्टिविटी किसके इक्वल हो जाएगी? आर के इक्वल। इन टर्म्स ऑफ सिंबल्स वी आर टॉकिंग अबाउट, वो तो वही रहेगा, यूनिट उसका वही रहेगा, ओम मीटर ही रहेगा। ठीक है,
यस मैम, थैंक यू।
हमने सिंपल इंटरप्रेट किया कि इफ वी पुट L1 A1 then rho comes out to be equal to R. This is how we can relate the things and define resistivity, right? Okay, now answer my question. Did I tell you what is conductance? Anybody knows what is conductance? So let us do what is conductance and what is conductivity, right? Conductance is defined as reciprocal of resistance. Conductance is defined as the reciprocal of resistance. So its formula becomes 1 over resistance. Symbol will be, its symbol is G. So G is 1 by R. This is our formula of conductance. G is 1 by R. So we discussed what does the slope of VI graph indicate? Resistance. So what will the slope of IV graph indicate? It indicates reciprocal of resistance or conductance. Okay, so make that out now. Slope of IV graph will indicate conductance, that means, because we said that it indicates reciprocal of resistance and that further is called conductance. Okay, so note this result that the slope of IV graph indicates conductance. Fine. Same way, can you write the unit? Unit लिख सकते हो conductance का? 1 over the unit of resistance, that is ohm. So the unit will become ohm inverse. We can also write ohm inverse like this. Okay. And we can also write the letters in reverse. We can write mho. So mho is also the unit of conductance. And one more unit is there, Simon, denoted by capital S. So any one out of these you can write. All these are units of conductance. ठीक है, either ohm inverse like this, inverse, or in terms of symbol, or you can write the letters of ohm in reverse order, mho it becomes, or Simon. These are the units of conductance. These are the units of conductance. Clear? Next term is conductivity. Same way, conductivity is defined as the reciprocal of resistivity. Resistivity का opposite है. Resistivity मतलब tendency to oppose the flow of current. Conductivity means it indicates the flow of current through a wire. ठीक है? So let us define conductivity. It is defined as the reciprocal of resistivity. Conductivity is the reciprocal of resistivity. Its symbol is sigma. This is again a Greek symbol. So sigma is 1 by rho. This is conductivity. Sigma is 1 by rho. This is the formula of conductivity. Fine. Now, who will tell me the unit of conductivity? 1 over the unit of resistivity. Unit of resistivity is ohm meter. So reciprocal of ohm meter can be written in same number of ways. ठीक है, साथ में बस मीटर इनवर्स आ जाएगा. ठीक है, so unit of conductivity will be ohm inverse, meter inverse, ohm inverse, meter inverse like this, mho meter inverse, or Simon meter inverse. Anyways, you can write. Mohr meter inverse or Simon meter inverse. Is that clear? Conductance, conductivity, resistance, resistivity, all these terms should be clear to you now. Fine. यहाँ तक कोई doubt? Yes, students. Okay. Yes, Arsheen. हाँ जी बोलो.
मैम तो फिर हम कंडक्टिविटी को मैम देन वी कैन से इट एज स्पेसिफिक कंडक्टेंस आल्सो.
नो सच टर्म एग्जिस्ट. ऐसी कोई टर्म एग्जिस्ट नहीं करती है. ठीक है. रेजिस्टिविटी इज कॉल्ड स्पेसिफिक रेजिस्टेंस. ठीक है. कंडक्टिविटी के लिए एज सच कोई सेपरेट टर्म नहीं है. ठीक है. चलिए, लेट अस राइट वन न्यूमेरिकल प्रॉब्लम बेस्ड ऑन दिस कॉन्सेप्ट ऑफ रेजिस्टेंस एंड रेजिस्टिविटी. Right? So write down a wire of original resistance R. A wire of original resistance R and resistivity rho is stretched to double its length. A wire of original resistance R and resistivity rho is stretched to double its length. ठीक है. जैसे एक रबर बैंड है, उसको हमने खींच के डबल लेंथ का कर दिया. ठीक है. ऐसी एक वायर है. Stretched to double its length. Calculate its new resistance and new resistivity. तो जब हमने उसको स्ट्रेच कर दिया, आफ्टर दैट कैलकुलेट इट्स न्यू रेजिस्टेंस एंड न्यू रेजिस्टिविटी. ये आपको फाइंड करना है. So we'll definitely use the formula R is equal to rho L by A. But before that, before solving, we can make out that resistivity will remain the same. Because I told you कि जब हमने length को change कर दिया, कुछ भी कर दिया, resistivity does not depend upon dimensions of the conductor, so resistivity will remain the same. ठीक है. तो resistivity new जो है वो भी same रहेगी. आप पहले एक आंसर आपका आ गया, but with proper reasoning you have to mention. Okay, so your answer of resistivity will be it remains the same because it does not depend upon dimensions of the conductor. Fine. So let us calculate new resistance now. But before that, I must tell you, when we stretch the wire, it gets doubled in length, but it becomes thin also. Have you noticed कि हम एक वायर को खींच के डबल कर देते हैं, पर वो थिन भी तो हो जाती है ना. तो अगर हम उसकी लेंथ को डबल लेंगे तो उसकी थिकनेस को हाफ लेंगे. उसका एरिया ऑफ क्रॉस सेक्शन विल बी हाफ than before. This is not given in the question, but if you don't take it into account, your numerical will be wrong. So you have to think, you have to imagine the situation always when you do some numericals. ठीक है. तो ये mere cramming नहीं है, इसमें हमें mind apply करना होता है. Right? So let us solve that. Original resistance R is equal to rho L by A. This is equation number 1. So this is original resistance given, that is R is equal to rho L by A. Now new resistance will be rho L dash over A dash. Rho dash, why I have not written? Because I am saying that resistivity remains the same. तो resistivity को मैंने rho ही लिखा, वो change नहीं हुई, वो rho की rho ही रही. Length change हो रही है, area of cross section change हो रहा है. ठीक है. तो उसको मैंने लिख दिया L dash A dash. Now what is L dash? Length has become double, so L dash is 2L, and area of cross section gets halved because wire becomes thin also. So we will put A dash equal to A by 2. So let us put the values 2L A by 2. 2L and A by 2. Solve this. 2 ऊपर आ जाएगा. So 2 into 2 rho L by A. What is rho L by A? What is rho L by A? That is previous resistance R. So 2 into 2 4. So R dash, that becomes 4 times. So new resistance is 4 times the original resistance. Okay. So on increasing length, on decreasing area of cross section, resistance of the wire will increase definitely, but how much? it will become 4 times. So resistance increases 4 times. All right, resistance increases 4 times then. All right. Yeah. Okay, so let us start. Resistance. How does it vary with temperature? Next factor. By now we have done 2 factors: length of conductor, area of cross section of the conductor. Third factor on which resistance depends is temperature. So when we heat a conductor, when we heat a metal, what will happen? The electrons, they will get kinetic energy. On heating, they will gain some kinetic energy, and because of that they will start moving about more vigorously, और ज्यादा जोर जोर से वो collide करेंगे. ठीक है? So number of collisions will increase और एनर्जेटिक हो जाएंगे इलेक्ट्रॉन्स आफ्टर गेनिंग टेम्परेचर. जब भी हम किसी चीज को हीट करते हैं, हैव यू सीन द वाटर बॉइलिंग? सो यू मस्ट हैव सीन कि वाटर मॉलिक्यूल्स कैसे इधर इधर जाना शुरू कर देते हैं ड्यूरिंग बॉइलिंग व्हेन वी हीट वाटर. So we can see the water particles moving here and there randomly, ठीक है, rapidly. So that's why on gaining temperature, they gain kinetic energy, they become more energetic, they collide more. And since the cause of resistance is collisions, again the resistance will be more. So note down, for conductors, the resistance increases with increase in temperature and vice versa. So, and when we will cool it, then electrons will become passive, they will become less energetic, they will collide less, and resistance will decrease this way. Okay? So see how the resistance of conductors varies with temperature. This is the reason. Okay? That on heating the conductors, I repeat, they become more they get more kinetic energy. Okay? Electrons, they become more energetic, they move about more vigorously, they collide more with other electrons. Since the number of collisions increases, resistance also increases. ठीक है? चलिए